Right now, as you're watching this video, Earth is losing 3 kilograms of hydrogen every single second for 4.5 billion years straight. So why do we still have air to breathe? Why haven't our oceans vanished into space? And on a distant planet with only 1% atmosphere remaining, how can massive sand dunes taller than your knees still move across the surface? 2 planets, 2 impossible mysteries that defied scientists for decades. One answer that will change how you see life itself forever. Just half a volt. Weaker than a watch battery, but powerful enough to save an entire world. To begin this story, we need to go back to 2012. The Curiosity rover had just landed on Mars. The mission? Climb Mount Sharp, a 5-kilometer tall mountain sitting right in the middle of Gale Crater. But before starting the journey up the mountain, Curiosity had to cross a massive field of sand dunes. The name? Bagnalled Dunes. But there was a major problem. Mars's atmosphere is only 1% compared to Earth's. If you stood on the Martian surface, the atmospheric pressure would be equivalent to an altitude of 35,000 meters on Earth, higher than commercial airliners fly. Wind blows across the surface, but it's extremely weak. According to basic physics, wind that weak shouldn't have enough force to move sand. Scientists predicted that these dunes would remain frozen in place forever, but they were wrong. Completely wrong. This is the exact same location. The image on the left from 2012, the image on the right from 2015. This dune had moved 2.4 meters in 3 years, with only 1% atmosphere. How could this possibly happen? The first secret lies in the grain size. The Opportunity rover analyzed Martian sand and discovered something remarkable. The grains are 4 times smaller than sand on Earth. Earth sand ranges from 0.1 to 2 millimeters. Martian sand? Only 0.05 to 0.5 millimeters. And here's where the physics gets interesting. Mass is proportional to radius cubed. That means if the radius halves, the mass decreases by 8 times. You only need 1/8 the wind force to move them. The second reason is gravity. Mars's gravity is only 38% of Earth's. When wind lifts sand particles into the air, they fly 2.6 times higher. And when they fall back down, their impact kinetic energy is much greater. One grain hits the surface, bounces up, and launches multiple other grains into motion. This domino effect propagates across the entire surface, and the dunes begin to move. The final reason is wind. Mars experiences massive dust storms. In 2018, one storm engulfed the entire planet. Wind speeds reached 100 meters per second, equivalent to 360 kilometers per hour. 10 times the wind needed to create dunes on Earth. And here's the key. Wind force is proportional to velocity squared. If velocity increases tenfold, force increases 100 times. Enough to compensate for the thin atmosphere. But that was just ordinary dunes. When Curiosity rolled across Bagnalled Dunes, it discovered something strange. The surface wasn't flat, but extremely rough. Very rough. Massive ripples appeared everywhere. They stood 50 to 150 centimeters tall, knee-high to a person, spaced more than 1 meter apart. To understand how special this is, let's compare with Earth. When you walk on a beach, ripples measure about 3 to 5 centimeters high. In the Sahara Desert, slightly taller, around 10 to 15 centimeters. But on Mars, 50 to 150 centimeters, 10 to 50 times larger. If you walked across these ripples, it would feel like continuously climbing up and down stairs. So, why are they so massive? Scientists believe this results from 3 factors combining. 1. Much stronger winds. 2. Particles jump higher due to lower gravity. 3. Smaller grain sizes. Combined together, they create a structure type that Earth doesn't have. The name TARs, short for transverse aeolian ridges, transverse wind-formed ridges, not regular ripples, not small dunes, but something in between. And here's the most astonishing part. From orbit, with cameras at 30 centimeter resolution, we cannot see these ripples. They're too small. Only when the rover arrived on the surface did we discover them. We've explored Mars for 40 years, but only learned these existed 10 years ago. So why doesn't Earth have this type of mega ripple? The answer lies in fundamental differences between the two planets. First, atmosphere. Earth has an atmosphere 100 times thicker. Wind disperses evenly, not creating such extreme structures. Second, gravity. Earth has gravity 2.6 times stronger. Sand particles can't jump high. They fall quickly, reducing impact kinetic energy. Third, moisture. Earth has water. Wet sand sticks together, resisting movement. Mars is completely dry. Sand moves freely with the wind. Fourth, vegetation. Earth has plants holding sand in place. Plant roots stabilize the surface. Mars has nothing. The surface is completely bare. This discovery isn't just an interesting detail. It helps us understand how wind operates in thin atmospheres, critical for future missions. It also tells the story of Mars's climate history. This planet once had a thicker atmosphere, but while Mars lost its atmosphere, gradually becoming a barren desert, Earth remains vibrant and blue. So what protects us? The answer lies in an invisible force that took humanity 60 years to measure. In the 1960s, when humanity had just begun exploring space, scientists discovered a strange phenomenon, an invisible wind blowing from Earth's poles out into the cosmos. They called it polar wind. What made this wind special was that it wasn't like anything we'd ever known. It wasn't ordinary wind that we feel on the ground. This was a stream of ions, electrically charged particles, escaping from Earth's atmosphere at astonishing speeds. Scientists measured that every second, thousands of tons of material were leaving our planet through the poles. But the biggest question was, what creates a force powerful enough to push these ions beyond Earth's gravity? Gravity pulls everything down. So why are these particles flying up and escaping into space? That was the mystery that science took 60 years to solve. For 6 decades, the scientific community debated endlessly about the origin of polar wind. Some hypotheses suggested it was due to thermal pressure, high temperatures in the ionosphere pushing particles outward. But calculations showed that temperature alone wasn't sufficient to explain the ion's escape velocity. Others believed it was due to solar radiation, ultraviolet rays, and charged particles from the sun blowing away our atmosphere. But this model also couldn't fully explain what we observed. There was some force, an invisible force, at work here. And this force had to be strong enough to push heavy ions like oxygen upward, overcoming Earth's gravity. But what was it? The first clue came from a place we never expected, our sister planet, Venus. A world that had lost its dense atmosphere and transformed into the molten hell we see today. Venus and Earth were born nearly identical. Same size, same mass, relatively similar distance from the Sunday, but today they are two completely different worlds. Earth teems with life, while Venus is a scorched desert with temperatures of 460 degrees Celsius, hot enough to melt lead. In 2021, while studying data from the European Space Agency's Venus Express probe, scientists made an astonishing discovery. Venus also has an ambipolar field, similar to Earth's, but much stronger. Venus's ambipolar field generates an electric potential of up to 10 volts, 5 times that of Earth. This number may sound small, but on a planetary scale, it's enormous. This electric field force is strong enough to push oxygen ions out of Venus's atmosphere at terrifying speeds. This was the crucial clue. If Venus has an ambipolar field, then Earth must have one too. And perhaps this is the mysterious force behind polar wind. But to prove this, we needed to directly measure Earth's ambipolar field, an extremely difficult mission. In May 2022, NASA launched a special rocket from the Svalbard archipelago in Norway, one of the closest places to the North Pole from which humans can launch rockets. This mission was named Endurance. Why launch from the Arctic? Because the ambipolar field is strongest at the poles, where Earth's magnetic field lines touch down on the planet. This is the ideal location to measure this phenomenon. The Endurance rocket flew to an altitude of 768 kilometers, beyond the ionosphere, where the ambipolar field operates most powerfully. It had only a few minutes to collect data before falling back, but those few minutes changed everything. For the first time in history, we accurately measured the strength of Earth's ambipolar field, approximately 0.55 volts. Though small, this number is enough to create an invisible force pulling light ions like hydrogen upward at speeds exceeding 1 kilometer per second, faster than the speed of sound. But, more importantly, data from Endurance confirmed the ambipolar field is the main driver behind polar wind. The 60-year mystery was finally solved. So, how does the ambipolar field work? Imagine the ionosphere as an ocean of charged particles. Here there are two main types: electrons, light and agile, and ions, heavy and more sluggish. Electrons, being lighter, tend to fly into space faster, but when they do so, they leave positive ions behind. This creates an electrical charge imbalance, positive on one side, negative on the other. And here's the magic. Nature hates imbalance. To maintain electrical neutrality, an electric field forms, the ambipolar field. This field has two simultaneous effects. It pulls electrons back, preventing them from escaping too quickly, and simultaneously pushes positive ions upward, helping them overcome gravity. The result is an invisible electric wind, a plasma stream controlled by electromagnetic force, not mechanical force. This is why oxygen ions, though 16 times heavier than hydrogen, can still escape into space at astonishing speeds. The ambipolar field is essentially a bridge between planet and cosmos, a natural mechanism allowing the atmosphere to breathe and exchange matter with space. Now, let's place Earth and Venus side by side to see the terrifying difference. Earth has a 0.55 volt ambipolar field, strong enough to maintain the polar wind, but not so strong as to strip the atmosphere bare. We lose about a few tons of oxygen per second, but this is a very slow process and can be replenished through geological and biological activity. Venus? Completely a different story. With a 10-volt ambipolar field, nearly 20 times that of Earth, Venus has been and continues to lose oxygen at a horrifying rate. Scientists estimate that over the past few billion years, Venus has lost an amount of oxygen equivalent to a 100 meter deep ocean, covering the entire planetary surface. Why this difference? The answer lies in the magnetic field. Earth has a powerful magnetic shield, created by our spinning molten iron core. This shield protects us from solar, wind, and limits the intensity of the ambipolar field. Venus? No magnetic field. No shield. Solar wind acts directly on the atmosphere, amplifying the ambipolar field to terrible levels, and gradually stripping the planet of its atmosphere and water. The question arises, could Earth become a second Venus? The good news is, no, at least not in the near future. Our magnetic field is still healthy, and will remain so for billions of years to come. But this also reminds us of an important truth. Our atmosphere is not something we should take for granted. It's protected by invisible forces, magnetic fields, ambipolar fields, things we've only just begun to understand. So we've journeyed from a simple question, why does Earth have water, to the deepest discoveries about how our planet works. We've seen that water isn't just simply here. It's the result of an enduring battle between cosmic forces, gravity holding us together, the ambipolar field pushing our atmosphere outward, and the magnetic field protecting us from solar wind. Earth stands on a fragile boundary between life and death. Looking at Venus, we see what can happen when this balance is broken. A planet that could once have resembled Earth is now merely a scorched desert. But this isn't just a story about science. It's a reminder of how fortunate we are. Every drop of water we drink, every breath we take, all exist thanks to the perfect balance of invisible forces. In this vast universe, Earth is a rare exception. And our mission is not only to understand it, but to protect it. Because once we lose this balance, as Venus has lost, there is no way back. Thank you for joining me on this exploration journey. Look up at the sky tonight and remember, we are living on a miraculous planet. If you enjoyed these cosmic and scientific discoveries, don't forget to subscribe and hit the notification bell so you won't miss our next videos. Like and share if you found this video helpful. Leave a comment to let me know what topic you'd like to explore next. See you in the next video.